All right, today we're going to look at some more trig integrals like we did yesterday. For this first one, we looked at this Pythagorean theorem trig identity yesterday of sine squared plus cosine squared equals 1. What happens if we divide all the terms by cosine squared? Well, what that would turn into then is another trig identity that you saw back in trig, that we get sine over cosine we know is equal to tangent. So tangent squared plus cosine over cosine would be 1 equals 1 over cosine we know is the same as secant. So secant squared x. And what we're going to use today, or see today, is a bunch of trig integrals that have sine and secant in them. So when we are doing sine and secant, we're going to want to use this identity to help us out. All right, so what should we be looking for if tangent and secant are part of the integral? What we're going to look at is two things. One, if the power of secant is even, then what we're going to do is save a secant squared out of that integral, because what we know is derivative of tangent equals secant squared. So if we are trying to do the antiderivative, that helps us out. And then what we're going to do with the rest of it is use that trig identity we just had to replace the remaining factors of tangent. Okay. If we don't have that secant is even, then we're going to look to see if tangent is odd. If tangent's odd, we're going to save a secant tangent out of that, because we know the derivative of secant is secant tangent. And then again, we're going to use that same trig identity to replace the rest of the secants. All right, so let's try some of these out. So first one, we want to evaluate this integral tangent to the 6th power of secant to the 4th power. So in this one, what we see is that we have an even power of secant. If you have an even power of secant, we want to leave a secant squared. So we're going to think of this integral as tangent to the 6th power, and we're going to split that secant squared up into 2 of them, because we ultimately want to save that. Okay. What we're going to do then with the rest of the secants is replace it with that trig identity, and that trig identity we know says that secant squared is equal to 1 plus tangent squared. So we're going to rewrite this integral here as tangent to the 6th. Secant squared is equal to 1 plus tangent squared times this last secant squared. And we're holding on to that again because now we're going to do a substitution. We're going to substitute for all those tangents over there. And we know the derivative of tangent turns out to be secant squared. So that's where that secant squared is going to go away. So this right here becomes our du. All these other tangents are going to become are going to get replaced by u. So this will end up being u to the 6th power. And then we got 1 plus u squared here, all times du. That should now be a lot easier integral to do. We'd want to simplify that one last time here before we do the antiderivative. So distribute that u to the 6th. And now we can do both of these. Go up a power, so we got 1/7 u to the 7th, 1/9 u to the 9th, plus some possible constant. And our last step is to now substitute back in those tangents, and we get the answer of 1/7 tangent x plus 1/9 tangent to the 9th power x plus u. And that would be the antiderivative of this one. All right, let's look at another one. On this one, we're going to want to do this one. Now here, got a hint up here. We want to take out this common factor here. We see both of them have tangents of even power. Let's factor out a tangent first. So if we factored out not just a tangent, but a tangent squared, since both of them have it, what's left over here is 1. If we divided tangent squared by tangent squared, we get 1. Plus, if we divide tangent to the 4th by tangent squared, we'd have 2 left over. Okay, and what do we know 1 plus tangent squared equals 2? That's our trig identity there. That's equal to secant squared. So we end up with tangent squared x times secant squared x dx. We see that we have an even power of secant here, so this is similar to our last one. Why don't you pause the video and see what you can come up with on this one and see if you can solve it out. Okay, let's see what you got. Again, we want to make this substitution of tangent. Here, derivative then is secant squared. So if we substitute in, all this becomes our du. And this is going to become u squared here. So we got u squared du. Antiderivative would be 1/3 u to the 3rd plus c. And finally, substituting back in, this should be hopefully the answer that you came up with for the antiderivative. All right, let's look at some different ones here. So this one now, you can see we don't, this one's not even here. So if it's not an even one, then we want to look at the tangent. Our tangent is an odd one. So on those ones, that's where we're going to want to save. We want to save a secant tangent. So what we're going to do is we're going to rewrite this one. We're going to take one tangent, one secant out of both of these. So it's going to be tangent to the 4th power now of theta, secant to the 6th power of theta, because we're gonna separate out a secant tangent out of this, because we know that's the derivative of secant. So what we're gonna do now is ultimately we're gonna substitute in here secant in for u, because we know the derivative is secant tangent. So all this should turn to our du here eventually. The problem is right now, we can definitely substitute u in for these secants, but this one is not a secant. So here's where that same trig identity is going to be used. We're going to substitute in for tangent. And we know that tangent in this trig identity, tangent squared is equal to secant squared minus 1. It's just moving that 1 to the other side. Remember before we had that secant squared equal to 1 plus tangent squared. We're just subtracting that 1 now over to the other side. So what we have here is, since we got tangent to the 4th, we do have secant squared minus 1. That would be for tangent squared, but since this is to the 4th, that means we'd have to square this. We got tangent squared to equal that tangent to the 4th power, times this other secant to the 6th, times all this other stuff. Okay, so now if we make our substitution here, we should have it. This is going to turn into u squared minus 1. This is going to be u to the 6th power, and then all this other stuff turns into our du. Now this one, there is some simplifying we're going to need to do on this one, because we can't quite yet come up with this antiderivative with that multiplication still happening. So we are going to have to FOIL out 2 of these, and then multiply that last u to the 6th. So if we'd multiply 2 of these terms of u squared minus 1, we'd get u to the 4th power. There'd be 2 negative u squareds, and then -1 times -1 would be +1. Now we got to multiply that last u to the 6th all the way through. Remember, when you're multiplying, add power, so u to the 10th minus 2u to the 8th plus u to the 6th. Now we can finally find the antiderivative of all these. So go up a power for each one with reciprocal in front. this is going to be ninths, so we're going to have a 2 ninths here. This one's going to go to the 7th, so we got 1/7 plus some possible constant. Last step now, substitute all those secants back in, and we got it here. So we got secant to the 11th power. This one's going to be to the 9th power and to the 7th power. And that would be the antiderivative of all this. So whenever you have an odd power of tangent, that's what we're looking to do on those ones. All right, same thing. I want you guys to try one out here. Notice again, we have an odd power of tangent there. So see if you can separate out one of those secant tangents and solve this one. So pause the video, try it out, and see what you get here. All right, let's see how you did. So if you're separating this one, we're going to have tangent squared now times a tangent and a secant. And that's good because we know when we do our substitution here of secant that we end up with secant x tangent x. But since we're substituting secant here, we do have to use that trig identity over here. So this would turn into our secant squared x minus 1 here. Okay, so when we substitute, here's our du. And this is going to turn into u squared here. And so we got u squared minus 1 du. And that one shouldn't be too bad to find the antiderivative of. Now we got 1/3 u to the 3rd minus u plus c. And finally substitute back in, and we got our answer. So there's the answer, hopefully, that you came up with. All right, next problem. What if it's only tangent? How do we go about doing only tangent? Well, we definitely can't use that trig identity because we need tangent squared to do that. And we don't have any derivatives of trig ones that end up only being tangent. So then we got to think differently here. What else do we know tangents equal to? Well, if you go all the way back to what you did on some of those trig identities back in trig, we know tangent can be written in terms of sine and cosine. And that's what we're going to do here. Tangents equal to sine x over cosine x. And by doing that, we can solve this one. Now, it is a substitution problem. We got to either substitute for sine or substitute for cosine. Both derivatives have the other one in it. But it doesn't work too well here if you do it for sine, because even though the derivative is cosine x here, that cosine doesn't cancel out, because if we substitute here, both cosines would end up on the bottom, and that doesn't work. So we actually have to do the other one. If we do cosine equal to u, now it will cancel out here. So derivative's negative sine x. If we move that negative to the other side, now we do have stuff that's going to cancel here. Sine x dx, we see right here, that should substitute for a negative du, just like this is going to turn into u. So if we make that substitution, I'm going to put the negative out front. We'd end up with 1 over u du. And that's an antiderivative. We know antiderivative of that would be natural log. So it would be natural log of the absolute value of u. It is negative plus c. And then we can substitute back in now that cosine into our answer. And so we get negative natural log of cosine x plus c. That would be one possible way to write the answer. It's definitely not incorrect. That's the correct answer. One other way you could see this answer written, though, remember if you have numbers in front of the logarithm, in this case this is like a -1 here. Remember there is log properties that say you can take that and bring it up as an exponent. So what would this end up equaling if we did that? It'd be natural log of cosine x to the negative 1 power plus c. Well, if we do that, remember something to the negative power, that means it's in the denominator, so we could write it as cosine x to the first power down there. Well, what do we know 1 over cosine x is equal to? That would be natural log of secant x. So that's something to think about. If this is a free response, that's definitely correct. If it's one of those multiple choice ones though, and you aren't seeing this answer, that probably means you're going to have to work to get it to that answer. So keep in mind some of those little things they might do to you on those multiple choice questions on the AP exam. All right, so last question here. What would we do on this one? All right, so let's look at this here. It's an odd power here. So that's telling us we want to leave a secant and a tangent. Right now, though, we don't have another secant. So what do we do here? Well, we can for sure separate out. We can for sure separate out a tangent still. We could write this. We still got 3 tangents here. And we could do that trig identity again in for tangent squared. So we know tangent squared is the same as, secant squared minus 1. And it would still be times the second tangent out here. Let's distribute. So if we distributed, now we got secant squared x tangent x minus another tangent x because we're distributing. So we got that second one there. Well, how do we do this one? Well, now if we look at this, what do we got here? It's not an odd one anymore. It looks like we actually end up with an even power of secant over here. So what we can do is that substitution. Now we don't want to get that substitution mixed up with this other tangent that we got over here. So it'd probably be better if we actually thought of this as 2 separate integrals now, as secant squared tangent x, this integral minus this other integral of tangent x dx. So if we see an even power, we know the substitution we want to make is for tangent, because what's the derivative of tangent? Secant squared. So this would turn into our du, and this would, there's our u there. We're not making that substitution on the second one because then we don't have that secant squared to cancel out. So we're going to keep just this in. Okay, so what's antiderivative of this side? That's easy. That's 1/2 u squared plus a constant. How about this other one though? Well, this is just the problem we just had from the last slide, and we've done that one. We know that comes out to equal either negative natural log of cosine or natural log of secant plus c. So using what we just had, we should be able to finish this problem now. We know this one comes this one right here comes out to equal natural log of secant x plus some constant. So now substituting back in, we would have the answer to this one. It'd be 1/2 tangent squared x plus natural log secant x plus c. So when you get these secant tangent ones, look first, is secant even? Then use the substitution of tangent. If tangent's odd, then we want to save a secant tangent and use u equal to secant. All right, try these additional problems out and see what you come up with.